Okay, and here we are. Hey everyone, welcome to our second live stream of CDK Live. Really excited for today's show. But before we get into the show and we start talking about all the great stuff that Fred's gonna teach us today, wanted to just start with a quick recap of kind of what's been going on and what's ahead in the CDK world. And before we start, really the focus I wanted to dive in on is reInvent. So reInvent's coming up. It's at the end of November. So it's starts November 26th. And if you're heading to reInvent and you want to learn more about the CDK, first of all, there's going to be the CDK product team's going to be there. We have some of our engineers that build the product are going to be there, and they have some really great sessions. So I want to quickly just show folks that the session catalog so you can see, what's ahead, what's coming up. So if you have, you're going to reInvent, you've signed up, definitely check out, you can search for CDK. We have quite a few sessions coming up, and a couple that I wanted to point out that I think are going to be really helpful for folks. One around CDKs. So if you're really interested in, Kubernetes, and, a lot of times when we talk Kubernetes, there's a lot of YAML. Some folks don't want to be diving into YAML all the time. So if you're interested in defining your Kubernetes manifest programmatically using a general programming language, CDKs is going to definitely be something you want to check out. So we have a talk on CDKs. And then we also have some talks around building constructs. So, we had a show just a couple weeks ago with Pahud, one of the solutions architects here at AWS. And if you know CDK and you follow, the GitHub issues and pull requests, there's a good chance you've seen Pahud in there. So we do have a great show you can check on CDK Live's YouTube page for how to build constructs and how to publish them on your own. And the last thing I'll mention with reInvent is, of course, I would say probably one of my favorite parts about reInvent or any of these AWS conferences is when you can get hands-on and actually dive into the the services and features and various products. So we have a couple workshops at reInvent where you can actually you can dive in and build constructs, as well as a workshop on just getting started with the CDK and just building and playing around with it and getting familiar with it. So that is the reInvent update that I have. Now what I'd like to do is just get back into the show and really what we're here for today. So, I'm just going to say that, I've been building in AWS for a long time, and I can tell you the one thing that always is something that's maybe not top of mind at first when you're building, but very quickly what you can find is that if you keep building things, you don't pay attention, costs can kind of surprise you sometimes. If you're not paying attention to what you're building, you don't delete things. So Fred is here today, and I'm going to hand it off to Fred, but he's going to show us a really cool open source project that him and his team have built around cost and budget management with the CDK. And I'm going to just stop there. Fred, why don't you jump in, introduce yourself? And also, Fred, by the way, you are a community hero. So that's another program. If you do a lot of stuff in the AWS world, I definitely recommend checking out our Heroes program and our Builders program. These are just great ways to kind of show off that you're like an ambassador, on behalf of AWS, and because you do so much cool stuff around the community. So definitely check that out. Fred, take it away. Really excited to have you here, and go ahead.
Thank you very much for the warm introduction, Adam. I'm very glad to be here tonight with you. And for sure, I will speak a little bit more. I will share with you what I've learned and what I've built over the previous months with reInvent, which is a company I started 3 months ago. The main idea of reInvent is to, like Adam said, make sure developers can experiment in a safe place. And to do that, my team and I have been working on a specific solution to control your spends on AWS and avoid surprise cloud bills. This product is composed of two main parts: an open source project for which we will on which we will have a discussion, and a SaaS product for people that does not want to dive too much into the infrastructure. If you want to check it out, I'd love you to have a try and give me as much feedback as possible to help make AWS a safer place to experiment without any fear of a surprise cloud bill coming up at the end of the month. The GitHub repo I'm mentioning is the CDK cost limit repository from Revent.io workspace. Project I've been working on for quite a long time, and we're getting close to a bit more than 400 stars at the moment. So thank you very much for the support on this great project. And I want to share today with you a little bit more about the internals of the project and how it's working and specific points that we'll dive into. So like I said at the beginning of this introduction, this specific package aims at making sure that budget on a specific AWS account remains within certain limits. And to do that, this package will export CDK constructs to disable resources using non-destructive operation when those mentioned budgets are hit. What we want to do, I want to emphasize this again, is to make sure that individuals can, without any fear of making mistake in their application or misunderstanding service pricing models, end up in a bad situation where costs become a problem. Main focus of the CDK cost limit library is a CDK aspect. And I want to take the opportunity today to share with you a little bit more about what CDK aspects are and how to use them. If you look at the CDK documentation, you have a whole section dedicated to what are aspects and how they can be used. And the probable use case that you already have in your application will be to actually tag resources. Tagging system in CDK is built on top of aspects and leverage those functionality to be able to add tags to any of your resources. So what are aspects? Aspects are an interface that you can implement in your CDK code base to add CDK deploy time or synthesis time, add functionality and modify or check certain properties of your construct. I have just here a small example of a simple aspect. So this particular class just here, what this aspect is doing is making sure that every resources provision in a specific CDK application have a destroy removal policy. So whenever the CloudFormation stack is removed or the CDK application is destroyed, those resources will for sure be removed from my AWS account. As you see, creating an aspect is as simple as implementing a specific interface, the iAspect interface exported from AWS CDK lib. And this interface only requires to specify a visit method that will take as argument every node of your CDK application and run on every of those nodes the code that you would have specified in the visit method. So what I'm doing here is basically saying for every node that you give me at CDK deploy time, please apply removal policy of destroy on the specific node. A node is a point in your tree of your CDK application. Whenever you're using a CDK construct, a level 2 construct from the AWS CDK lib, you're actually manipulating, you're actually handling a CDK construct, a node that will be invoked within this specific aspect. I showed you how to define an aspect, but this is not enough to be able to use it. Once you have defined an aspect, you just have to use this specific implementation to actually use this aspect on any part of your application. And you see two things in this line 36 on the code I'm showing you. You have the instantiation of the aspect itself, and you have as a first argument a scope here, which is this. It could be a specific construct that you defined before, or like I am right now in a specific stack. This will refer to the stack. So basically, when I'm writing this, I'm saying, please make sure that all resources that are part of this scope have a destroy policy applied. So whenever I destroy the stack, no resources will be left behind. I hope so far everything's clear. If you have any question on aspects and how to use them, feel free to use the chat. I'm sure Adam will make them pop up so I can answer them.
Yes, of course. So aspects, maybe, Fred, can you give us some other use cases where aspects would make sense? Now, and I know obviously, this project is a great example, but what are some other areas where you'd see where someone would implement an aspect? And I'm going to go another step with this question is, when would I want to implement an aspect versus maybe just building a construct or extending a construct for my end users? When would it make sense to do one versus the other in your opinion?
The framework I have in mind to decide whether it should be building a new construct or using aspect is the quantity of resources of construct that you will actually need to create in a specific construct. So for example, let me answer first your first question, and this will make a lot more sense. Another use case for aspect is, like you can see in the aspect documentation from CDK, checking specific constraints that you want to enforce in a stack. For example, here, making sure that all buckets that are provisioned in an application have versioning enabled. And you can do this using aspect. And this is much better to use aspect here rather than creating your own version of an S3 bucket as part of your construct internal library with this version configuration property override to enabled, because you are not packaging multiple constructs that build together a new piece of infrastructure. You're just enforcing a rule. You're just using a single construct. And when you use a single construct, usually it means that you would be better off using aspect than using a construct, an intermediary construct. I don't know if you share the same framework to know which one is best, Adam, but if you have another point of view on that, I'd be happy to discuss it as well.
Yeah, no, I think that's a great point. And I think, when building constructs, you have to also, there's a little more to it, right? You have to build and manage that construct. You have to, push that construct to an artifact repository, and there's versioning. There's, a little more work that goes into that, where sometimes it just makes sense. You want to just enforce using the aspect. I do think, and this brings up another point where we definitely don't need to dive into this today, but this is another show that what we're definitely going to have is, when do you want to look at, when building constructs, composition versus inheritance, and when it makes sense to use one versus the other, right? And so I think that's something, another time we'll definitely dive into, because I think that you could have a whole show on that too. But
yeah, that's
great explanation. Thank you.
Thanks. So I showed you already two examples of aspects. One, to make sure that the removal policy on all your resources are set to destroy. One, to check that every bucket in your application, at least on the scope on which you apply the aspect, have versioning enabled. And now I would like to share with you the specific topic of tonight's discussion. It's an aspect to enforce a budget limit on a scope of resources. And this is the main export of this CDK cost limit library that I've been working on with my team. And using this aspect is as simple as, of course, installing as a dependency the CDK cost limit using your favorite package manager, and applying using this aspect of add implementation that I showed earlier, a specific cost limit with the amount that you want to. Oh, sorry, I was clicking everywhere. So let's say I have a specific construct that I want to budget at $10. I can do it with all the resources that are included into the scope as simply as just adding this line of code. This does not really showcase how aspects can be leveraged here, but let me show you another example, a bit more complex, where I have an application, a CDK application that is bootstrapped. Within this application, I have a stack. And within my stack, I have 3 level 2 constructs, 2 function, and 1 EC2 instance. So I have an application, a CDK scope, which is a bit wider. So I have my application scope, then my stack scope. And inside my stack scope, I have 3 distinct scopes, which are the EC2 instance and 2 Lambda. What I can do using aspects is to set budget on smaller part of the scope. So for example, only on a specific Lambda. So this line would actually add a budget of $2 on the first Lambda function. This line would add another budget of $5 on the second Lambda function. And this line would add a complete global budget limit of $10 on the stack. So this as well includes the EC2 instance and the 2 Lambda functions.
So, okay, I got to ask this question because this is really cool. So when you look at this, I mean, this simplifies, creating budgets. Now, when you say, so I'll ask, it's kind of a 2-part question, but I'm just going to start with the one. I tend to do this, Fred. I tend to ask one question and then it leads into 20 other ones. So thank you for sticking with me here. But the first one here is, so when you set that budget through this project, what does that actually mean? Like, what is it going to do when you set a budget?
So, okay, first question. When you add a budget, what will happen is a few things. First of all, for this library to be able to do its work, a few additional resources that you don't see listed here will be deployed as part of your CloudFormation application. Those additional resources are actually used internally to keep track of the current expenses of budgeted resources, and will also take part in the disabling of responsible resources. The responsible in the sense that the resources that drive budget above the limit, to make sure that they can disable those resources until the end of the billing period.
Awesome.
If you want, I can show you. Go ahead. Maybe you want to ask your other question before I dive into a concrete example for Lambda function, for example.
And I think, I tend to do that is I tend to jump ahead, and I know you're going to go through that. So I'm just going to let you continue on because I know you're going to get into that. So great answer. Thank you.
So let's take a look at, for example, first, how this library works. What are the various parts that are actually provisioned to ensure budget are enforced? And we'll take a sneak peek at what's the exact implementation, for example, in order to prevent a budget from being exceeded in the case of Lambda function. So this library, like I said just before, is going to add additional resources as part of your CDK deployment. You have 3 types of resources that will be added when you use CDK cost limit aspect on your stack. You'll have a whole bunch of resources which are called common resources that will be used to enforce budget limitation and that are not specific to where you applied your budget limitation, on which scope you applied your budget limitation in your CDK application. And you will have construct-specific and typology-specific resources that will be provisioned whenever there is a specific type or instance of type of resources that is in your application. So in this example application, I have 2 EC2 instance and 1 Lambda function, all being part of a budget limitation using the CDK cost limit library. I will have common resources deployed, whether I have only a single EC2 instance to be covered by a budget or those three. But construct-specific resources and typology-specific resources will only be deployed if, for typology-specific resources, one instance of this specific typology of resource is covered, and construct-specific resources on each instance that needs to be covered. Those three different types of additional resources that will be provisioned by the library are very important to keep in mind when I will show you just now how it works exactly, for example, for Lambda function. So let's take a look at what happens under the hood when you protect a scope of your application that contains Lambda function. Part of construct-specific resources will be, for example, additional environment variable that will be accessible by your Lambda function. One concrete use case of those additional environment variable will be, for example, the budget amount that this Lambda function is under the constraint of. You will have typology-specific resources that will be provisioned. And in the case of Lambda function, it will be two layers, one for ARM processor and one for x86 processors that will be available for all the Lambda functions that might be covered by a specific budget and that will be added to your Lambda function in order to enable those budget limiting functionalities. And finally, you will have a DynamoDB, the one holding the current expenses of each budget that you define in your application that are part of the common resources typology of resource, the last one I showed just before, and that will take care of actually following how much has been consumed by each Lambda. In this example, for Lambda function, you have every time the Lambda is invoked, the layer that will be responsible for handling telemetry event, saying, I have been invoked for 2 seconds and I was configured with 1 gig of memory. All those information are relevant to actually compute a contribution to the budget for this specific invocation of a Lambda function. And the layer will update budget that is stored in DynamoDB to keep track of how much has been consumed. One important part of why this library had to be designed this way is, once again, making sure that budgets that you specify in your CDK application are kept under control. And when you say, I don't want to go over $10 or $1,000, you really don't want to go over those amounts. This requires to actually put a new compute engine, a new billing engine, to keep track real time of the actual accrued expenses of all your resources that contribute to a budget. Because if you use the AWS billing API to keep track of how much any of the resources has contributed to a budget, you'll be notified worst case scenario once a day, and that could result in actually shooting over the budget limit when you realize that the last update of budget was actually over the $10 or $1,000 limit that you set up. So that's why one big part of this project, and that was a little bit complicated to implement, was to be able to actually re-implement a real-time billing engine that would ensure we keep track of the budget. The second part of this library that was quite tricky, but nice to implement, was how do we actually disable resources when budget is reached? So in the case of Lambda function, the layer that is responsible to update budget to DynamoDB will receive the updated budget every time it increments the accrued expenses. And there is no off switch on Lambda. But there is a tricky way to actually say, please do not get invoked anymore. And this is to actually use the Lambda function concurrency parameter and set it to 0 to prevent any invocation slot from being available for this specific Lambda to be invoked. And this prevents additional cost being added to the budget.
So
Um,
this is
yeah.
really clever. So basically, you created this because in order to do this through the billing API, it's hard to get this data in real time, right? Like
Yes.
to get these metrics in real time. So you implemented this so we can, in real time, this basically this I'll call it an engine can, as you call it, like this engine can see in real time if we hit where we are within our billing requirements, and if we pass our threshold, we can actually limit and stop the function from invoking. So, I just see this as a great way for, developers that, you're running in development environments, you have cost constraints, obviously maybe in production, that's not something you're thinking about.
Sure.
You don't want to probably stop your functions in production, but we know that when you're developing in the cloud, we build ephemeral environments. We're constantly, you want to test as close to the real world as possible. So we always talk about, test. People like to test locally for things, but you really want to get, if you want to get a real experience, you want to test in the cloud. But also, you want to make sure that you're not going crazy. And if you leave something running overnight and you're constantly triggering functions, you do something where things go out of hand, you have this kill switch that will essentially ensure that you don't go over that limit and you don't wind up accruing costs that are out of your control. And you really don't see that anywhere. Like, this is a really cool project and really innovative in that aspect to be thinking of those types of scenarios. So this is really cool.
Thank you, Adam. Yeah, I like to think it's quite cool. It was really a lot of fun working and trying to find ways to implement such functionality. But it does come from somewhere. I did experience surprise bill by the past, forgetting about a specific Lambda that was a recurring trigger before this protection was enabled by AWS. And this led to a quite nice surprise in the morning. So this really was the motivation behind we should have building blocks available to have safe space to experiment. Of course, this is not for production. To have safe space to experiment and make sure that we don't end up with a surging bill at the end of the month.
And Fred, so a good question did come in from someone from LinkedIn, which was, so isn't this correct that adding a layer to all the Lambda functions itself and writing and reading from a Dynamo table on each invocation does increase cost in some way too? So
yeah, it does. No, it's true. One of the first things that I do showcase in the beginning of the library is the trade-offs that you have to make when you start using it. But I tend to be as transparent as possible on those specific trade-offs. The first one, of course, is availability. When you disable resources, part of your application will not be responding anymore and functionality will not work as you expect. Cost is part of the trade-off as well, because like you said, having a layer plus writing to DynamoDB and using control plane API in some of services can result in additional cost. For the example of Lambda, I did run the calculation to make sure those costs remain within a reasonable range. For example, Lambda function using the default quota from a brand new AWS account can generate, if you make them run quite a lot, and if you use the highest setting, you can generate easily over $1,000 in expense in each region in a brand new AWS account, just by having recurring Lambda calling itself. When you look at this exact scenario of having a Lambda running continuously with frequent invoke at higher setting for whole months, this is close to, if I remember well the math, around $600,000 in Lambda billing. For those $600 in Lambda billing, the costs that would result for DynamoDB would be $13. So it's really a very small fraction of the actual cost of the resource that you're monitoring, but it does exist, and you're right to point it out. The ambition of the library is to, of course, keep this cost contained and make sure that it's as small as possible. And I'm really happy to welcome implementation optimization that could result in less interaction with AWS or less additional resources that need to be provisioned to have those budget limiting features in the application.
And just it's a follow-up question is, would this still add to the cost? So like just by invoking the function, how do you address that? So we've set the concurrency to 0, we've hit our budget. What does that look like on the back end? Are we still incurring costs from reading Dynamo and all that?
In the case of Dynamo, the Lambda function cannot be invoked anymore. So the layer that was responsible to add consumption to the budget is not invoked anymore, is not run anymore. So you won't have, once you hit the budget, you won't have additional call to DynamoDB to update a budget that is already overshoot, because the Lambda function, which is running the code to actually update the budget, is not triggered anymore.
Makes sense. And then how does that, and you may go into this, so if I'm jumping ahead, forgive me. How does this project think about that? Like at what point does it then reset? When do we go back to, okay, we can start invoking the function again?
So the usual life cycle of this library is basically you start your development, you build your construct, you build your application, and using aspect and using the CDK cost limit aspect, you set a specific budget on one or many parts or many scopes of your application. If and when limit in this budget is reached, budgeted resource will be disabled automatically, and you can at any point restore them manually. Each service has a documentation to show you how to actually re-enable disabled resources. Basically, you're doing the reverse operation of the disabling operation. So in the instance of Lambda, instead of putting the function concurrency at 0, you would remove the function concurrency configuration to set it back to what it was before, so using unreserved concurrency. If you don't manually restore resources, there is a specific scheduled job at the end of each month, since billing period in AWS are based on months duration, that will do the re-enabling of the disabled resources.
Awesome. Very good. Thank you. And with the streaming software, I'm sorry, it doesn't show who asked the question, but thank you for the question. It was a very good question.
Yes,
thank you very much. Further follow-ups, please feel free to add them in the chat.
It would be a good time if I give a quick demo of the limiting budget capabilities, especially on the Lambda function, if you want to. It's not very shiny on everything, because what we're dealing with at the end of the day is the AWS console to show resources and a sub-process that will be inside this. There is no front end to show, but I'd be happy to showcase a little bit what it looks like.
So Fred, yeah. Quick question. So again, I know you'll probably get into this too, but so as of today, what compute platforms, what services are supported with this project?
Not much at the moment, and at the one of the main call to contribution that I have, if you want to contribute to this project, is to help me support more and more resources. At the moment, Lambda is supported and part of EC2 is supported. And I'm currently working on RDS cluster and ECS cluster. But if you'd like to see as a priority some other services and resource typology being supported by the library, the onboarding way, the way to add new capabilities to support those resources is quite straightforward and explained in the documentation. But I'd be happy to help you implement those, and I welcome any contributions that would add support for more services and resources.
Awesome. Thank you.
Let's go back to the demo time. So I prepared a small CDK application that deployed a CloudFormation stack that you can see here. In this CDK application, we have the common resources that are deployed by the CDK cost limit that you can see at the top level of the application under the Revent core node. And part of that, for example, is the DynamoDB table that is responsible for storing the accrued expenses of budget of your application. And in this demo application, I have handler construct, which contain a Lambda function, of course, a Lambda function, which is budgeted with the CDK cost limit library. And what I would like to show you is what's the result of implementing this budget. So whenever you trigger the Lambda function, which is budgeted in the application, anytime you do that, the layer that is provisioned as part of the Lambda function will interact with DynamoDB and add contribution of the last invocation to the budget. So in the DynamoDB provision in this stack, you see that I have one item that has been added. This item uses only a single partition key schema. And this partition key is basically the months of contribution, since we are on a monthly billing basis, and the address of the construct on which budget was applied. The address of the construct on which budget was applied is used as the unique identifier of a budget, and that's all any sub-resources within a scope know on which budget they need to contribute. I tricked a little bit the demonstration, but just to avoid having to actually incur some cost on my demo application to show you how it's disable resources. But I tricked it, and I actually said that current expenses of this application are close to $1. If you want, I will showcase a little bit what is the unit I'm actually using to keep track of the budget. But this number represents basically $0.999999. What I will do is go on my terminal and start invoking my Lambda function. As you can see at the moment, this is the Lambda function I was showing in CloudFormation that is part of the budget of $1 that I have on this specific construct. And at the moment, you can see that the Lambda function has a configuration for concurrency to use unreserved account concurrency. So basically, I can invoke it as much as I want. When I switch to my console and actually ask for 10 sequential call of Lambda invoke of this specific function, you will see, if everything goes planned, perfect, it does, that my Lambda function is being invoked successfully. And at some point, the contribution of the Lambda function will actually result in it not being able to be invoked anymore. So as you can see, the Lambda function here has just been shut off, and the remaining 3 executions for this Lambda function could not succeed. The Lambda service actually throttled my request. If I go back on the AWS console to see what changed on the Lambda function and just refresh this page, you can see that I will have a nice blue banner at the top of the Lambda function saying that this specific function is throttled and cannot be invoked because the reserve concurrency is set to 0. So that was, in a nutshell, a small demonstration of budget being activated. And if I go back to DynamoDB and look at my budget accrued expenses, I see that I just went over $1. And that's what's triggered the Lambda function from self-disabling itself.
Nice. So, okay, I mean, this is really cool. So basically you like, it's nice. Obviously you don't want to accrue a lot of costs in your demo account. I get that. So you have to tweak the system a little bit, but having the ability, and again, I want to reiterate, there's 2 things I want to reiterate here. One, that, when you're in a larger organization, you have a lot of people using the CDK, or developers testing and building things, but you want to control costs. This is a really great way to ensure that your developers can test at their frequency that they need to test, but at the same time, make sure that things don't get out of hand. And I think, the original comment earlier is definitely a good point to think about, that, like, if you're really cost conscious, and you don't want to, maybe this doesn't make sense for you, if that dynamo table, that additional cost there, it's not probably for these really tiny projects. But when you're building a lot, you start to build more complex environments. It definitely makes sense to have something that can keep an eye on your costs, because you don't see this out there. I don't know of a lot of tools that do this, that will not only check your cost, make sure that you kind of check a budget, but then stop from exceeding the budget. Like, I think this is a really cool thing that you don't see a lot out there. So I think there's a lot of potential here for this project, and I hope folks in the community, that one of the beautiful things about the CDK is it's open source. And not only is it open source, but you can build on top of this and make it, if you see there's a service out there that you want to see this interact with, like you mentioned ECS earlier, I could see ECS being a great one here, that at a certain point, you can just drop your task count to 0 for a service, and now it's no longer running. So there's just a ton of potential here.
Yeah, it does. I'm really convinced as well that this is a good way to move forward. I've seen a lot of teams in my development experience years that actually enforce a lot of rules to make sure developers do not use specific services because they are not familiar with it, and they don't want on the company level governance to actually incur cost for experiment sessions being done by a development team. But the better way to move forward on this would be to actually provide teams with safe space to experiment into. And one way to provide a safe space is to make sure that costs incurred on those experimentation accounts remained within limits acceptable to the company. And I think this is one way to move forward with it, rather than saying all those services cannot be used or should be kept under control and review by a specific DevOps team. I love DevOps team, and don't take me wrong on that, but restricting people is not the way to help them embrace new way to build on CDK and AWS. I do prefer the way of disabling afterwards if a mistake is made, rather than saying it's not allowed on the first basis. You know what I mean?
Yeah, absolutely. And it's, this is now with the next evolution of kind of DevOps, how it's involved into platform engineering. And, there's a lot of good that comes with, platform engineering. Again, you can build constructs that your developers can use. There's a lot of things you can do to help enable teams. But what we see that's so common is you create blockers, and these are unintentional blockers. I mean, it's, platform teams are well-intentioned. They want to do the right thing, but it's also, there's so much benefit when you can let developers experiment and, play around with these services, test them, and get familiarize themselves with it, but do it in a safe way. So I think there's always that balance of, enablement, but you also don't want to, block them from being able to experiment and build and test things. So there's a lot of potential with this project. And, the other thing I wanted to say was that it's just, again, this is one of the benefits of using a tool like the Cloud Development Kit, the AWS CDK, is you can build on top of this. And there's so many entry points for teams to come in, and this is such a creative way to implement through aspects, right? Like you implement that visitor pattern where you can, it's very seamless to the team building. You can build your code as you want, build your CDK app as you see fit, and then simply just pass in your constructs into this aspect, and then it's going to take care of enabling this for you. It's really cool. So Fred, I'm sure if you have more to say, please continue. But if there's, I know there's Revant, you also do some cool stuff with your company. So, at what point would you, tell us a little bit about what you're thinking ahead, for this project, and kind of where you see yourselves helping out in conjunction with this project as well.
That's a nice question. So basically, like you mentioned, and like we discussed a little bit earlier, part of the value proposition of this open source project and what I do at Revent is to make sure that we can experiment with as much services as possible, and supporting those services is the key part of the development for the open source project and the SaaS product. So basically, supporting more resources until one point where most of resources that are available are protected is one of the key targets on my key focus at the moment. While the open source project allows people that do CDK and that have teams available to implement the cost limit functionality within the application code or within construct libraries themselves, the product I'm building at Revent is doing similar functionality, but using an interface that does not rely on actually implementing within a software development lifecycle those limiting functionality, but it does exactly the same. It does, the internals work exactly the same way. It does keep track of your budget on a specific scope. It widens the scope notion outside of CDK usage, and you can actually implement, remove, restore, pause specific scope of your application at any point in time. So you don't really need to wait for a new PR to be merged for this to be able as part of the construct library. An additional thing that we're working on at the moment also is to have additional triggers to disable resources. So the most obvious one we talked about was reaching a specific budget, but we're working on as well on scheduling pause for environment. So this would be more targeted at, for example, for teams that have development and pre-production environment available internally for developers to see what they are working on and test feature before they go in production. Those environments don't really need to be up at night and during the weekends. And we're offering the same capabilities of disabling resources with various services supported at specific time instead of when reaching specific budget. Again, this is the beginning of the development of the company, and I would be very keen and very curious to know other use cases where you'd want a part of your application or scope of resources being temporarily disabled to avoid additional contribution to the budget. But if you want to try the open source project, feel free to do so on GitHub. And if you want to take a look at the web application that does the same thing, I'd be happy to have a chat with you. You can book a demo with me on the main website at revent.io. And let's see what your use case is and how I can help you handle disabling and re-enabling of resources within your AWS account.
Amazing. And so what is the best way? So two last questions. What's the best way for if someone wants to contribute to this project, what's the best way to do that? And two, if someone does want to reach out to you about, the your service, how should they reach out to you?
Contributing to the project, I'm welcoming any pull requests that you want on the GitHub repository. So I'd be happy for you that wants to contribute to actually request a specific feature or try to implement a new service. That would be really awesome. There is additional subject, if we still have a little bit of time, that I want to focus on, and I would be very willing to have the community propose ways to do those stuff. In particular, what I do have in mind, for example, is immunity. Immunity was a fun subject, as I mentioned before. Part of what this library does when using Aspect is provision additional resources that will keep track of costs that are incurred based on budgeted resources, and resources that will actually disable Lambda function or EC2 instance or ECS cluster or RDS cluster. Those resources, when deployed, are part of the scope which is under a budget, and they can, and I've seen that before. I was surprised while I was developing, see part of the limiting functionality being disabled because they were part of the scope. It was non-intentional, but it was hard to actually provide immunities for those resources. And the more services will be supported, the bigger the problem will come. So at the moment, I found a way around that. But if you want to contribute to this specific issue, feel free to reach out on the corresponding issue in GitHub, and I'd be happy to discuss it in more details and to help you contribute for the first time on the project.
Awesome.
Another thing
GitHub issues.
Yeah.
So if someone maybe go to the GitHub repo, submit an issue, and maybe that's a good way to interact and then figure out the best path forward.
Sure. Yeah, that's it.
Awesome.
And on the service itself, if you want to interact with me and check what we can do about the service itself, there is a big book a demo button. It's directly linked to my calendar, and I'd be happy to take some time to discuss it with you. So feel free to use it if you want to reach out and discuss a specific problem that you're facing.
Awesome. Okay. Well, I think that's it. I'm not sure if you have anything else to go over. Do you, Fred? Are we
No. It was really nice to have me tonight, Adam. Thank you again for that. It was very nice speaking about the project and showing the internals. There are a lot more stuff inside, and if anybody wants to deep dive on some other aspects, feel free to reach out to me using the book demo or the issue on GitHub. I'd be happy to help you and to find ways to continue to contribute on this project.
Amazing.
Thanks again for having me tonight, Adam.
Thank you, Fred. Thank you so much. And again, the links have been shared, but again, the GitHub repo is here below. And then, of course, the website for Revant is here as well. So, Fred, thank you so much. This was really insightful. Again, I just love to see all the cool stuff that people are building around the CDK to help make everyone's lives easier. This is a project that I think folks should keep an eye on. And again, it's open source, so that's the beauty is if you see something missing, contribute. Let's continue to make the project better and better to kind of suit the community's needs. So that's it for today. Again, we do have reInvent coming up. I will be at reInvent, so if you're going to be there, feel free to reach out to me on Twitter. It's at Real Adam J. Keller. LinkedIn as well, just Adam Keller. Reach out, let me know if you want to meet up, talk CDK, talk infrastructure as code, talk anything AWS. I love to do it. It's fun. But otherwise, we will we're going to probably not have any more live shows up to reInvent, and then after reInvent, we're going to have a whole set of new live streams coming up, as well as more content on getting started with the CDK. Whole bunch of really good stuff coming up here. So, Fred, thank you so much. Really appreciate your time today. Really cool project, and I can't wait to see where it goes. So, otherwise,
thank you very much for having me, Adam. Thank you.
Awesome. Well, we'll catch you all later, and we'll see you on the next stream. So, thanks, everyone.
Also, thank you again. See you.